Welcome back to Elementary Adventures. We're now on episode 4 in our place value series. By now, I hope you realize what a powerful tool our place value chart is. In previous lessons, we learned how digits can be shown with discs. We've also learned about regrouping and decomposing. In episode 3, we learned how to use our place value chart to find the standard form, expanded form, and word form of a number. Standard form is when we show a number using one digit in each place value. In expanded form, we take each digit in a number and multiply it with its place value. And finally, in word form, we learn that numbers can be written with words. Today, we'll be using our place value chart to find the standard form when we're given the expanded form or the word form of a number. In today's activity, we will once again use our modified place value chart that was introduced in episode 3, as well as a whiteboard marker and eraser. Let's go ahead and begin. In our first example, we see that a value has been given in expanded form. Now, let's use this to find the standard form. We learned in a previous lesson that when you show a number in expanded form, you multiply each digit in the number with its place value. Let's start from the left. It says 7 times 1,000. The digit 7 is multiplied with 1,000, which means that the digit 7 belongs in the thousands place. Next, we have 4 times 100. That means the digit 4 belongs in the hundreds place. Next, we have 2 times 10. So the digit 2 belongs in the tens place. And finally, we have 5 times 1, which means the digit 5 belongs in the ones place. As we learned in the last episode, we can use arcs in order to help us say the number correctly. So for this example, this is equal to the standard form 7,425. The comma separates the thousands period and the units period. Don't forget to include it in your standard form. Now let's look at another example. In this example, we have expanded form once again. How would this number look in standard form? Let's use our place value chart to figure this out. Starting from the left, I notice that 9 is being multiplied with 10,000. That tells you that the digit 9 is in the 10,000s place. The next part shows 3 being multiplied with 100. That means the digit 3 belongs in the hundreds place. Finally, in this expanded form, we see 4 being multiplied with 10. That means the digit 4 is in the tens place. So far, I only have 3 digits written on my place value chart, but I see some gaps. These gaps have to be filled. If you don't fill these gaps, this number looks like it's 934. But that's not what this number is. Let's go ahead and fill in the gaps with 0. There were 2 gaps to fill in with 0, in the thousands place and the ones place. Now I can show what this number actually is. Let's use our arcs. Remember, our arcs separate the different periods in this number. The first arc is in the thousands period. The second arc is in the units period. And therefore, there's a comma in between the first 0 and the 3. The standard form for this number is 90,340. If you're wondering, When can we fill the gaps with zeros? What about all these other gaps in these other place values? Well, the truth is, we can put zeros in all of those place values. This number remains 90,340 even if I put zeros in all the place values that have no digits. However, these zeros don't have to be there. If I removed these zeros, my number is still 90,340. The zeros that I have to keep are the zeros in the thousands place and in the ones place, because if we remove those two zeros, the number would look like 934. Now let's look at another example. Here is expanded form once again. Starting from the left, we see that 2 is being multiplied with 100,000. That means the digit 2 is in the 100,000s place. The next part of our expanded form is 5 times 1,000. That means 5 is in the thousands place. The last part in this expanded form is 2 times 1. And that's telling you that the digit 2 is in the ones place. Once again, we have some gaps to fill in with 0. The gaps that need zeros are the 10,000s, the hundreds, and the tens in this number. Those zeros have to be there. Otherwise, if you just have the digits 2, 5, and 2, it would look like 252, but that's not our number. Here are the arcs and the commas to help us say this number correctly. 205,002 units. So our standard form is 205,002. Remember that in expanded form, we don't have to show parts that equal to 0. Any digit being multiplied by 0 will give you a value of 0 and does not need to be shown in the expanded form. Sometimes in expanded form, you'll notice that when the digits are written out, it's not in the order that you will see it on the place value chart. Let's look at an example that shows this. Here we have 5 times 10,000. That shows that the digit 5 is in the 10,000s place. The next part in our expanded form is 2 times 10. That's showing the digit 2 is in the tens place. Wait a minute, our next value is 4 times 1,000. Well, that means we've got to go back to the thousands place and put the digit 4. Phew, thank goodness I had my place value chart to help me with that. The next value I see is the digit 7 multiplied with 1 over 100. That means the digit 7 is in the hundredth place. Finally, I have 3 times 1 over 10. Wait a minute, we've got to go back to the 10th place and put the digit 3. I do have some gaps to fill. Let me go ahead and do that. The gaps I filled were the hundreds and the ones. I could also fill the gap on the thousandth place with a 0, but that 0 will not change the value of the number. If I wanted to, I can leave that 0 out. Next, I have to make sure I show my decimal point. Finally, I add my commas and my arcs. Using my commas and my arcs, I can see that this number is 54,020 and 37 hundredths. I have to say hundredths because the digit 7 is the last digit on the right and it's in the hundredths place. Our standard form is 54,020 and 37 hundredths. This is standard form because there is one digit in each place value. In expanded form, we have 9 times a million plus 5 times 1,000 plus 3 times 1 over 100. Work with a partner to find the standard form for this number. How'd you do? This number was huge. The number that is on the place value chart is showing 9,005,000 and 300th. Here we have the word form 552. I'm going to underline digits and circle place values to help me find the standard form. I've underlined the digits 5 and 52. I've circled the word 100 that tells me what place value is being involved. I notice that 500 means the digit 5 is in the hundreds place. And 52 tells us 5 is in the tens place and 2 is in the ones place. Here I have the standard form 552. Here I have short word form 6,003. I underlined the digit 6 and the digit 3. I've also circled the place value 1,000. This is telling me that the digit 6 is in the thousands place. Next, I see the digit 3, but since it does not have a place value next to it, that means 3 is in the ones place. Remember, we could also put 6,003 units, but we normally don't see the word units because we understand that the last part of a whole number is in the units, period. In this example, we have some gaps to fill. This time, our gaps are in the hundreds and the tens. If we don't fill in those gaps and we just have the digits 6 and 3, this would look like the number 63, but that's not what we have. I filled in the gaps on the hundreds and the tens place with zeros. Finally, I drew my arcs as well as my comma to separate the thousands and the units periods. This number is 6,003. See how helpful the place value chart can be? In this example, we have the word form 39 and 5300ths. Anytime I see the word and written in word form, I put a box around it. Remember, the word and shows that there is a decimal involved. I start with the decimal on my place value chart. Remember, a decimal is a bridge between the whole number side of the place value chart and the parts of a whole side. Now I've underlined my digits and circled my place values. Let's go ahead and start from the left and work our way to the right. First, I have 39. I know 39 is going to be on the whole number side of the place value chart because it comes before the word and. 39 means I have 3 tens and 9 ones. Next, I notice that it says 5300ths. That means the digits 5 and 3 are on the right side or parts of a whole side of the place value chart. Let's double check. It says 5300ths. That means the last digit on the right, the 3, should be in the hundredths place. And it is. In standard form, the number is 39 and 5300ths. In this example, we have the word form 5,024 and 3,000ths. First, I notice that there is an and. That word tells us that there is a decimal involved in this number. I've underlined my digits and circled my place values. The digits I underlined were 5, 24, and 3. The place values were 1,000 and thousandths. Let's begin. First, it says 5,000. That means the digit 5 is in the thousands place. Next, it says 24, and there is no place value after it, which means it's in the units period. 24 means I have 2 tens and 4 ones. After the word and, I see 3 thousandths. So the digit 3 is in the thousandths place value. The gaps I have to fill are the hundredths, the tenths, and the hundredths. Here I have included my arcs as well as my comma. This will help me say the number correctly. The standard form is 5,024 and 3 thousandths. Sometimes it can get real tricky. Here I have 16 hundredths. 16 hundredths means there are 16 in the hundredths place value. Wait a minute, that doesn't work because standard form only allows 1 digit in each place value. In episode 2, we learned that numbers and digits can be shown with discs. In this example, we had 16 hundredths. I have shown 16 discs in the hundredths place. Remember, in our base 10 system, anytime we have a group of 10 discs, we can regroup them into 1 disc in the next place value on the left. Here I have regrouped 10 discs into 1 disc in the tenths place. So now we have 1 tenths and 6 hundredths. Let's put that on our place value chart. Since we're seeing digits in the parts of the whole side, we do need to show our decimal point. Otherwise, this looks like 16 wholes. And just to show that there are no values on the whole number side, I'm going to place a 0 in the ones. So our standard form is 0.16 or 0 and 16 hundredths. What would this look like in standard form? Work with a partner to find the standard form for this number. This is what our number looks like when we use discs. We have 1 tens, 2 ones, and 13 tenths. As we learned in episode 2, when we have a group of 10 discs, we can regroup them into 1 disc on the place value to the left. So this time we had 10 discs from the tenths place being replaced with 1 disc in the ones place. So now we have 1 tens, 3 ones, and 3 tenths. When we show that with just digits, we can say that our standard form is 13 and 3 tenths. 13 and 3 tenths is also equivalent to 12 and 13 tenths. In today's lesson, we use concepts that we learned in episode 2 and 3 to help us find the standard form when we're given word form and expanded form in numbers. With every lesson, your understanding of our base 10 number system is getting stronger. I'm so proud of you. Happy learning, students. Bye.